Hello, everyone. Thank you for the introduction, Dider. I am pleased to be with you today to present a few indicators and trends about the household sector in the EU. So a quick reminder about the Odyssey project, which is supported by the EU Life Clean Energy Transition Program. The current project is coordinated by the ADEME, the French Agency for Ecological Transition, Enerdata, who is the technical coordinator for the Odyssey database, and Fraunhofer, who is the coordinator of the Mure database. And of course, all of this wouldn't be possible without our 14 national partners in the 27 EU member states, 9 energy community countries, as well as Switzerland. Dider, can you confirm that everyone hears me well? All is okay at this point?
Yes, we can hear you. Thank you, Zineb.
Perfect. So in today's presentation, we relied on indicators and data from the Odyssey database, and a few information about the sources of our data. So we rely on Eurostat for aggregate data, on data from national partners for indicators and data up to 2022. And we also provided early estimates for data and indicators for 2023, which are calculated and computed by Enerdata. Just a note that for consumption indicators and more advanced indicators, ambient heat has been removed from consumption and indicators. Bruno will explain later why this was important for us to do, as it gives or it overestimates the consumption for the sector if we keep ambient heat. This data and indicators is available on the website, on the link that you can see on the screen. So you can access the Odyssey database, as well as 5 different tools. So the first tool is the key indicators tool, which gives us, and it's indicated by the name, a few indicators about energy consumption and efficiency at EU level, at EU member state level. The market diffusion tool, which gives information and indicators about the diffusion of energy efficient technologies and renewable energy technologies in the EU. The decomposition tool, which analyzes drivers behind energy consumption growth. Comparison tool, which allows and enables comparison between countries. And lastly, the energy saving tool, which allows to track progress in energy savings across the EU in different periods of time. So for today's agenda, we will begin with an overview of some macro indicators for the household sector, followed by a review of energy consumption and energy efficiency trends. And then we will conclude by a few key messages and key takeaways and open the floor for your questions. So a quick reminder about the policies that are in place for the household sector at EU level and at EU member state level. A few of them have been implemented and also translated at EU member state level. And these policies are primarily focused on supporting renovations. 2 main policies to look at that we are presenting is the Energy Performance for Buildings Directive, and it's a 2024 version. This policy introduces a binding target to increase average energy performance of the building stock, with the specific targets for 2030 and 2035. It also introduces a unified energy rating scale for our member states, which enables comparison between member states, and also an obligation for property owners to provide energy performance certificates to buyers or tenants. The second policy or measure that we're looking at is the renovation wave strategy, which provides an action plan with regulatory financing and enabling measures to boost building renovations, with a focus on fostering deep renovation and a target to double the annual energy renovation rate by 2030. So to start, we will look at a few macro indicators for the sector. which you can see on the table on the right side of the slide. So the data that you can see indicates a stable share of the sector in the total consumption, in total electricity consumption, as well as in CO2 direct emissions. We can also observe an improvement of the emission factor of the sector. A few good news about the mix of the household sector, with an increase in share of electricity, heat, and renewables, and a decrease in share in CO2 emissions. Now let's look at energy consumption trends with this first slide, which compares the evolution of private consumption, average energy prices for households, and energy consumption for households, broken down in 3 different periods on the charts on the bottom left corner. I think you can't see the years on my screen. I can't see the years, but the periods that are shown on the chart are 2010, 2014, 2014, 2019, and 2019, 22, sorry. So what we can see from the data is a decline in energy consumption at a rate of 3% per year since 2020. So that's the dark blue bar. And this is mainly due to surging energy prices, which increased by an average of 4% per year since 2019, with the bulk of this price increase happening in 2022, where the increase was at a rate of 20%. For the second period, or the period in the middle, we notice a slight increase in energy consumption, a rebound in private consumption, but a different trend for prices, which declined. Over 2010-2014, we can observe increase in prices, a stable private consumption, and sorry, I keep seeing messages popping. What I said is stability in private consumption, a decrease in households' energy consumption, and an increase of prices. Looking at a detailed view for 2 of these indicators for EU member states, we can see on this slide the chart that shows an annual variation of energy consumption and prices over 2019-2023 for EU member states. And here we have 2 main observations. So prices increased in most EU member states, with yearly average rates exceeding 5% in 11 countries. So these are the countries on the left of the chart that are surrounded by the light blue square. We can also observe that most of the increase took place in 2023. So it's the increase in prices, as we saw on the slide earlier. So this happened at EU level and also at EU member state level. And increase in prices happened with, of course, different magnitudes, which obviously depend on or are explained by differences in fuel mixes and national policies. So the second observation is that this increase in prices had a significant impact on energy consumption. So in most EU member states, we observe a drop or a decrease in energy consumption as prices increased, though we can see 2 exceptions for countries where energy consumption dropped despite a decline in energy prices. So moving on to unit consumption per dwelling. So this slide shows the evolution of energy consumption for permanently occupied dwellings in per dwelling. So what we can see at EU level is an average of 1.26 TOE per dwelling. We can also observe different unit consumptions per country, even after adjustment to the same climate. We can see on the far right of the chart, Malta with 0.47 tow per dwelling, and on the left side of the chart, Luxembourg with 0.1 tow per dwelling. But overall, the trend that we can see on this chart is a decline in unit consumption through the period 2010, 2022, in most EU countries. At EU level, the rate was -1% per year. Continuing with detailed consumption trends, we are now looking at a breakdown of energy consumption by end use. So the end uses that are represented on the chart are air cooling, lighting. Air cooling is in pink. Maybe you can't see it, but it's on the top of the bars. And the reason you can't see it is the share of air cooling, which is quite marginal. We have lighting, cooking, electrical appliances in light blue, water heating in orange, and space heating in dark blue. And the chart shows 2010 and early estimates for 2023. So as you can see, the dominant end use is heating. It was in 2010 and it still is in 2023. In 2023, it represented 64% of household consumption. Though the consumption has been slightly decreasing over the years at a rate of 0.6% per year. We can also see or observe a relatively stable share for water heating, electrical appliances, cooking, and lighting. But we can see that the lighting consumption has been decreasing over the years at a rate of 1.6%. And something important to note is the increasing consumption or the growing consumption for cooling, which has been growing at a rate of 5.5% per year over the period. But as I said earlier, its share remains marginal, as it's barely noticeable on the chart. On the following slide, we are looking at trends of electricity consumption. So again, by end use in 2010 and 2023. So here we have a different breakdown for end users. So we keep cooling, lighting, small appliances, large appliances, and thermal uses. So thermal uses are water heating, and cooking. So what we observe is that large appliances consume the largest amount of captive electricity. So it's electricity outside of thermal uses. And that, even though that this share is dominant, the consumption has been decreasing, while the consumption of small appliances has been increasing throughout the period. The electricity consumption for lighting is declining at a rate of 1.6 average per year since 2010. Though we can notice or observe a stable share, as you can see, 8% in 2010 and 7% in 2023. As I said earlier, cooling has seen its consumption grow over the period, but its share in total electricity consumption has remained marginal so far. And this was the last slide for this section on energy consumption trends. Now I hand it over to Bruno for more details on energy efficiency.
Hello, everybody. I will, after this overall picture of energy consumption trends, I will go into more detail to understand what is going on, and especially on energy efficiency. To track energy efficiency in Odyssey, we use various indicators of specific consumption, at the level of end use, that were the end use were presented before by Zineb. For instance, for heating, we have TUE per square meter, TUE per dwelling. For household, for water heating and cooking, TUE per household, a kilowatt hour per dwelling for lighting, kilowatt hour per appliance for different large appliance and cooling. Let's see some of these end uses to illustrate the trend in the indicator we are using, starting with space heating. The household space heating consumption per square meter, which is the indicator we are using to measure energy efficiency trend for space heating, has been decreasing in all countries since 2000, and at EU level, the decrease has been around 1.7% per year. This reduction was very rapid in 6 countries, above 2.5% per year, and even close to 3% for most of them. What is interesting, and as was shown before, there are different periods, so we will focus on the most recent period, and especially since 2010, we have 3 periods, as shown by Zineb earlier. We have a first period until 2014, then 2014-19 and 2019-22, the last period. I will start with the last period. What is interesting to note is that there has been a net acceleration of the reduction trend of the heating consumption per square meter. It reached 2% per year at EU level, which is even above the decreasing trend observed before 2014. And there was a rapid reduction in the majority of the largest consumer. This graph focused, because it was complicated to show the 27 countries, on the 10 largest consumers in terms of heating consumption at EU level, and they represent 85% of the heating consumption, with a dominant share for Germany, 25%, France, Italy, and Poland. The share is written on the footnote below. This acceleration since 2019, of course, can be related to the strong price increase, which mainly occurred in 2022, but maybe to more intense effort in energy efficiency, although we have tried from the few data available to confirm this trend, but the period is too short and the data still limited, especially to be able to monitor on a yearly basis renovation works. We have a limited number of countries for which data are available, and for this country, we don't really notice a great intensification. Before 2019, and this is also difficult to explain, the decrease was much lower than before and after in half of these large countries, especially in Germany and the Netherlands, and even in Poland, this unit consumption increase. I remind you that over this period, the price were decreasing, which contrasts with the period before and the period after. And also there was a rebound in income, average income per household, which is captured by the private consumption per household. Now, if you shift to another end use, which corresponds to the large appliances, refrigerator, freezer, washing machine, and so on, you can see that the specific consumption measured in kilowatt hour per appliance has decreased very rapidly since 2000, thanks to all the measures implemented, labeling, eco-design, and so on. The trend has been between 4 and 5%, with washing machine recording the larger decrease, followed by cold appliance and the other appliance at 4% per year. We do the same for cooking, water heating, lighting, but I don't have time to show all of them. So the question now is, from the information, the trend we have observed for heating, I remind you since 2010, now I focus on the period since 2010, on average, minus 1.4% per year for heating, minus 0.8% per year for water heating, minus 2% per year for refrigerators. The question is, what is the overall energy efficiency progress for the sector? And it's where we use an indicator that we call ODEX. And for people familiar with the Odyssey project, this is something we have developed for all sectors as well as for the overall final consumers. ODEX is an index that measures the energy efficiency progress at sector level. How is it calculated? We look at the trend in the specific consumption by end use, as illustrated for space heating and large appliance above, and we express it in variation index to account for the fact that we have a diverse unit. You have seen TUE per square meter, kilowatt hour per household. So we have multiple units, and using index of variation, we remove the unit. And then we calculate an average index for the sector by weighting the indices by end use by their share in the household energy consumption. How to interpret the ODEX? For instance, an index of 80 in 2022 with the base year 2000, which is the base year we are using for the moment in Odyssey, means a reduction of the index by 20%. Which means that energy efficiency improved by 20%, or expressed in percentage per year, and I gave you the formula below the screen. It indicates a decrease of an increase of energy efficiency of 1% per year. Looking at real trends, you can see, and this is the black line, that household energy efficiency improved by 30% between 2000 and 2022 to 23. We have an estimate for 2023, which mean an energy efficiency improvement of 1.5% per year. And most of the progress was achieved before 2014 and after 2019, with a net slowdown between 2014 and 2019, as we have seen before for space heating, which is the dominant end use. Progress has been mainly driven by energy efficiency gain for heating, lighting, and large appliances, whereas for cooking and water heating, we are not able to measure any improvements in 2014 from the data available. Energy efficiency improvements means we are saving energy. So in Odyssey, we calculate the energy saving, and here we are providing the annual additional saving by period for the same period as before. And what is interesting is that since 2020, annual additional saving have rebounded since to their historical level of around 5 million ton oil equivalent per year. This represents the equivalent of 2% of the household consumption, which can be put in perspective with the Article 8 target, which correspond to all end-use sector, and has a different definition because the saving should be related to policies, whereas here what we measure is, of course, the impact of policies, but also the impact of prices and the impact of autonomous technical progress, the fact that people will buy more efficient appliances because the market is going into that direction, although there are no necessary policies behind it. Heating represents the bulk of this saving with a share that higher than its consumption share, with a share of savings of 84% of the household sector since 2020, and a bit less in the period before, compared to its share of 64% of the consumption. Now, if we look at the total saving and compare them with the saving by sector, The savings for the household sector reached 92 million ton oil equivalent in 2023, which is the equivalent of 39% of the household consumption that year, which means that without this saving, the energy consumption would have been 39% higher in 2023. Households are overrepresented. This is shown by the two pie chart below the screen in the total saving, with a share of total saving much higher than its share in consumption, 39% of saving for household, whereas its share in consumption is 28%. Household is a sector which has the highest number of AU measure. So the AU measure is linked to directives. Over 50% of the AU measures are dealing with the household sector. But if we look at the overall number of measures by countries and the Mure database, which is also developed in the project, and able to see the measure by sector, and the share of household is not really higher than the share of measure in transport or in services, for instance. What has been the impact of this saving on the energy consumption of households? So I go back to the first graph that was shown by Zineb on the energy consumption trends of household, and I will try to explain what have been the factor behind these energy consumption variation. Looking at two periods, on the left from 2010 to 2019, and on the right, the most recent period since 2019. All this is available from the decomposition tool that is on the website of Odyssey. You can play with the periods. So here we selected some periods. So looking at the first period, 2010-2019, the consumption decreased a little bit, only by 6 million ton oil equivalent, which is very small at AU level. And here we are dealing with the consumption at normal climate, as was the case for what was shown before. And the increase in the number of dwelling and what we call the effect of lifestyle, the fact that people have more appliances per dwelling, larger homes, what we summarize in terms of activity effect, contributed to raise the consumption by 21 million ton oil equivalent, which was more than offset by energy saving, which reached 26 million ton equivalent. Since 2019, the consumption decreased sharply by 12 million ton oil equivalent. The activity effect, so the combination of lifestyle, number of dwellings, and so on, contributed to increase the consumption by 11 MTOE. And this was more than offset by energy savings, minus 18 million ton oil equivalent, and behaviors, which is shown in black, which represent the effect of people reducing their consumption, mainly because of price effect or sufficiency measure that were promoted, especially since the situation in Ukraine and tense situation on the supply of gas. Now, if we look at the real consumption, so we don't take into account, we don't look at the consumption at normal climate, but a real climate with the same period, you can see that the effect of the climate, which is shown by the pink bar, was almost the most significant factor over the period 2010-2019, because 2019 had a much warmer winter than in 2010. And it explains the reduction of the consumption by 29 MTOE. And the other effects are the same as what was shown in the previous slide. Between 2019 and 2023, the climate effect also had an impact, which is less important. because of the warmer climate in 2023 compared to 2019. And this effect from 2019 to 2023 was almost equivalent to the behavioral effect. In conclusion, the consumption has declined rapidly since 2020, partly due to the increasing energy prices. As shown by Zineb, the price effect had different impact among the countries, and it's not always easy to explain. It has to be related to the level of price, income of countries. So it needs to be looked at countries by country. Because of the large climate variation over the years, and this was illustrated in the previous slide with the 3 years we picked up, it is important to analyze trend at normal climate, which is what has been done all over this presentation. But not always it is done when people analyze the trend in consumption. Then I go back to the issue of ambient heat, as said by Zineb. It has been removed from all the data and indicators that were shown. This ambient heat is the heat that heat pump is extracting from the outside air or from ground or water. And in our review, it should not be included in the household consumption because it gives a wrong signal as to actual consumption variation. Why? Because heat pumps, which are very efficient mode for heating, have the same efficiency as an usual electric heater, that is say 100%, if we count the ambient heat. In the Eurostat statistics, energy balance, the ambient heat is included in household consumption, and it gives a wrong signal as to real trend in the household consumption. However, to monitor the energy efficiency according to EED, the Energy Efficiency Directive, this ambient heat is removed, so we are following more or less the rule of the monitoring of the Energy Efficiency Directive. Just to illustrate the impact of including or not the ambient heat, the space heating consumption per square meter, which is the indicator we use to monitor the energy efficiency of heating, decreased by 1.3% per year at EU level without the ambient heat, but only by 0.9% if ambient heat is included. So this shows big impact of using data with ambient heat or without ambient heat. Energy efficiency improved by 1.5% per year since 2000, with most progress achieved before 2014 and after 2019. Progress has been mainly driven by energy efficiency gain for heating, lighting, and appliances. Energy saving for household reached almost 100 million ton oil equivalent in 2023, with a rate of additional annual savings since 2020 back to their historical trend after a period from 2014 to 2019, where they had significantly reduced. And since 2019, consumption at normal climate decreased by 12 MTOE, with the combined effect of energy saving and behavior, which more than offset the activity effect. Now I thank you for your attention, and we are ready to take some questions.